Okay, very good. We're ready for the big time.
Question, how would you put that as a question again?
Okay, I can say, draw the list out structure for me. I can say, how many triples, how many doubles, how many singles, how many lone pairs on the central atom. Okay? And remember, I said pair, so it's 2 pairs. Maybe 4 electrons, but it's 2 pairs. Okay, let's do this polyatomic ion. Can anybody name that? Carbonate. Excellent, Sarah. Carbonate. Okay, now everything we've done to this point has been neutral. If you have carbonate ion, I like to put parentheses to isolate that charge to show it's just a -2. The whole thing is carrying. Has it gained electrons or lost electrons? It gained, and how many? 2. It stole 2 from somebody. So we're going to go through, and we're going to have to take that into account. So we've got something new here. We've got an ion to deal with. Okay, the carbon needs how many, Liz? Okay,
I don't know why.
remember it's total need. Think music.
8.
8.
Sorry.
Okay, because carbon's not going to violate. And then I have 3 oxygens. Liz, guess how many each one of those need? 8. Good job. So what have we got here?
So my brain just went out.
What's that?
So you put me on the spot, so I'm just.
Oh, yeah. So, you know, stress sometimes kills the brain. I've been in situations where, God, I'm paralyzed because I think I gotta do this, I gotta do that. Somebody just asked me a question. My God, what do I do? Yeah. So stress kills brain cells. Plus, you can't focus and do well. That's why on the test, you gotta do something to calm yourself down. Okay, let's get back here. Okay, so we got 32. 32 that are needed. Okay, now let's think available. The carbon, because that comes with how many?
4.
4. Each oxygen comes with how many, Marco?
6.
6. Plus, this is available, we stole 2. And so, here's the new part. If you're an anion, you add whatever, extra. So let's see, we've got 18 and 2 is 20, 24 available. Did everybody catch how we deal with that negative charge?
How did you just know the negative charge because we know it, right?
You know it.
Okay, go
You-
do it one more time.
Okay, this part right here?
Yes.
Okay, carbon came with 4.
Okay.
Each oxygen came with 6. We stole 2 from somebody.
If it was a negative charge, or a positive charge, would be subtracted?
Yes, yes, yes. And we will do one of those today. Good question. Brittany?
On the test or whatever we're using, are you going to give us the -2 or the 2 negative?
Yeah.
Is that going to be,
Yeah, I'll give you this.
okay.
It would be meaner to say, do the carbonate ion.
Yes, that would be.
Yeah, it would be meaner. Okay? But so, that would be double jeopardy. Because if you don't know nomenclature, you can't do those stuff. Okay, I will give you, here's your starting point. Okay, we got through this. So, how many are we going to share, Charles? How many are we going to share? 8. Okay, who's our central atom, Aaron? What?
Carbon.
Carbon, because we have just one of them. We put the oxygens around it. Okay, let me ask you some thought questions here before we start writing. Could I use a triple bond? Why not, Bruce?
Because you've got 3, you got to connect.
Okay, I got 3 different sites. I gotta have some shared. If I use a triple, I've blown 6 of these. And I only have 2 left, and somebody's gonna be left out in the cold. Okay, now I got 3 sites. Will 3 single bonds cut it?
No.
Okay, what's the solution to this dilemma, Brittany?
Having one double bond.
Yeah. Does it matter where I stick the double? No. I can put it on the left, I can put it on the right, I can put it down here. At this point in our career, it does not matter. Okay, now, all oxygens are not created equal because of this double. Okay, let's look at this oxygen right down here. And we want to complete its octet. So Meredith, how many more on this guy?
You need to add the
had 3 electrons?
3 pairs.
3 pairs. This guy over here, Tanya, how many? 3 pairs. This guy over here, Sarah,
3 pairs?
it's already got
2 pairs.
2 pairs. Okay, the carbon, how many more pairs? It's a trick.
Zero.
0. It's got a full house already. Now, when you do an ion, I would like square brackets and I want the charge showing. That's different than when we have something neutral. Okay, so there's our carbonate ion. At this point, let's check it. Okay, did we share 8? 2, 4, 6, 8. Check. We're doing great. Okay, we had 24 to use. We must use 24. Okay, here we go on the count. Andrew, this is what you asked about a second ago. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Check. Okay. Now, the other thing, the way you check the end of it is say, does everybody have its octet if it needs it? Well, that guy does. That guy does. That guy does. Does carbon? Yeah. That's our finished product. Okay, here are the questions. I got the carbonate ion. How many triples in it? None. How many doubles in it? 1. How many singles in it? 2. How many lone pairs on the central atom? 0. Okay? Now there are some lone pairs there, but they're not on the central atom. All right, great. Now, for Bruce, we are doing a cation since he had asked for one. Does anybody have a question on this one? You're doing great today.
And there wasn't no lone pair pairs connected to the.
They're all bonded.
They're bonding pairs. Lone pairs are unbonded pairs. That's another word for it.
The lone pair is on the outside.
Yeah.
So ammonia on this.
Okay, and that was going to be my question. What is that stuff? Ammonium, and Bruce just said the name of it. So that's okay. You just anticipated my question. That's fine. Okay, we're going to do this. If you're a cation and we got +1, what's happened to this thing? It lost 1 electron. Let's go through. Need, available, share. Okay. And here we have this ambiguity, and here is need, and there is nitrogen. Okay, the nitrogen, Nicole, needs how many? 8. We have 4 hydrogens, and each hydrogen needs how many, Allison? 2. Excellent. So we have a need of 16. Now let's think available. The nitrogen comes in with how many, Tran? Okay, nitrogen comes with 5. Each hydrogen comes with how many, Hina? 1. Now, what else do I have to do? Subtract 1. And so we end up with 8. Here's a good thing too, and kind of a double check. If I had forgotten to deal with this, I would have gotten 9. Chances are wonderful you'll never get an odd number, because you share even numbers and you end up with even numbers, usually. Now, anything can happen in chemistry, but for us, we're going to have even numbers. Okay, so here we're going to share, Andrew, how many?
4. Oh, I'm sorry. 8.
8. Okay, who's our central atom, Nina?
Nitrogen.
Okay, and I'm just going to put the hydrogens around it. Yeah, Sarah?
If you had like more than one central atom, would that be possible? Like,
Okay. Can you? Okay.
sorry.
Let me just do this. The rest of you can plug your ears if you want to. If you were sitting in an organic chemistry class,
Oh, that's the.
Cover your eyes too.
cover your eyes, cover your ears. Organic folks have a lot of trouble because they have these big chains of molecules. This is butane, okay, like butane you could use to cook stuff with. Okay, what organic chemists do is they go, okay, what if this is treat it like a central atom. You do that, and then you look at this guy, you go, treat it as a central atom, da-da-da-da, down the line. So for us, no. For them, yes. Okay? Okay, so, may I have a triple? Let's go back to ammonium.
No.
No, I can't have a triple. May I have a double?
No.
No way. Why not? There's two really good reasons not to. Meredith, why not?
Because you have 8 to share and you have 4 hydrogen, and each hydrogen needs 2, so you can only go 1 all the way around.
Exactly.
What was that?
Okay, we have 8 to share, and we have 4 bonding sites. So that means singles allowed only. That's one reason. She also slipped in the second reason. Each hydrogen only needs 2 or 1 pair. Hydrogens never take part in doubles or triples. And so for us, always the singles, and because it's an ion, we got to show the ion.